The great mathematical deception that 1 equals 0.99999 ad infinitum to infinity. My motto? Plain honesty, simple truth, easy understanding. The joy of finding things out for yourself. Following my upload on the same topic a month ago to YouTube, a definitive numerical demonstration that 1 equals 0.9999 ad infinitum, I visited the Mathology website on the same topic, with the result that I had a revelation that has led to this new upload. .99 really is equal to 10. Mathology is wrong. Matt and Jordan are wrong. So are these guys. As are these guys. As is this guy. The Cantonist troll Chris 5318 is also wrong. 1.4 million plus Mathology viewers are still clueless. So let's roll up our sleeves and put them right. 1. The finite series 0.9999 ad infinitum is, as is well known, generated by the equation y equals 10 to the n minus 1 all divided by 10 to the n for n equals 1, 2, 3, 4, 5, 6, 7 ad infinitum. The quotient of two integers, neither of which can ever be infinite. The length, i.e. number of nines in the resulting stepwise decimal expansion, is equal in length to the exponent n. All are finite. E.g. 9 divided by 10 equals 0.90. 99 divided by 10 equals 0.990. 999 divided by 1000 is equal to 0.9990. Y equals 10 to the n minus 1 all divided by 10 to the n reduces to y equals 1 minus 1 divided by 10 to the power n, which means we need only consider the series 0.99999 ad infinitum with no preceding integers. It is as plain as the nose on one's face from this slide that the series is not numerically infinite like the transcendentals pi and e, both of which have non-repeating decimal expansions, but that it always has a residual that is the reciprocal of an ever-increasing power of 10, which can always be split into two parts, 9 and 1, after increasing the numerator and denominator by 10. The series is therefore infinitely expandable in a stepwise manner, due slowly to the residual at each and every step, but no one in their right mind would attach any meaningful significance to it except a mathematician. The expansion can be stopped at any stage, no matter how small or large, and with the addition of the residual at that stage will collapse to give 1. So without the residual it is only ever an approximation, no matter how infinite the expansion and no matter what anyone else says to the contrary. 3. We know that 9 plus 1 equals 10 times 1 equals 10. So going from 0.99999 ad infinitum to 9.99999 ad infinitum is what? Addition or multiplication? Now multiplication by 10 just means adding a 0 to the end of the number and moving the decimal point one place to the right. It would then transform the infinite to the finite because of the 0 terminator. The integers avoid doing so in a deviously clever way that puts the mathematicians to shame, as will soon be shown. So what Mathology has done is simply to just add a 9 in his unjustified pretense of multiplication. Say that the infinite expansion is unchanged by it, so that the before and after expansions are unchanged. So cancel each other out after subtraction. An absolute falsehood. 4. In his Sell Ice Cream to the Eskimos video, mythology gives a slow motion justification for what had already been done by the Euler method. He converts the decimal expansion into their infinite sums of fractions, shows how each one gets converted into the larger preceding fraction that supposedly justifies the false deduction that the decimal expansion before and after multiplication are unchanged and thus the same because they are both infinite and therefore result in 0 on subtraction. This is wrong, because if I take 10 times 999.9990 I get 99999.990, which shows that the decimal expansion has contracted by one place, which, ignoring the integers, gives the difference between the decimal expansions of 0.9990 minus 0.9990 equals 0.0090 and not 0 as per the supposed infinite case. 5. The correct procedure for the presumed infinite case is as follows and is shown below. We can see that when we multiply the infinite series repeatedly by 10, that the only 9 that we can increase by 10 each time is the one following the 0 and its position in the series replaced by 0, QED. What we have done is to produce the original infinite series given by y equals 1 minus 1 over 10 to the power n plus a 0 at the start of the original infinite series. The combination of the two now form an infinite number of series of infinite expansion due to repeatedly multiplication by 10. Subtracting 5 from 6, we end up with 8.1 times 10 to the minus 5 and not 0. The two infinite parts of the two infinite series highlighted yellow cancel each other out to give 0 on subtraction. The series 90, 9.90, 9.990, 9.9990 ad infinitum produced by repeatedly multiplying the infinite series by 10 is given by the equation y equals 10 minus 1 all divided by 10 to the power n, for n equals 0, 1, 2, 3, 4, 5 ad infinitum. We get the total equation from y equals 10 minus 1 divided by 10 to the power infinity minus 1 minus 9 times 1 over 10 to the power n, where n equals 1, 2, 3, 4, 5 ad infinitum. 6a. In conclusion, it has been absolutely demonstrated that the infinitely expanding series 0.99999 ad infinitum cannot be multiplied by 10 without any regard to its effect on the infinite expansion, which is to repeatedly swap the position of the 0 and the 9 that follows it, i.e. 10 times 0.99999 ad infinitum equals 9.0999 ad infinitum. The 9's advance up the decimal expansion and the 0's down it with each multiplication by 10 recursively, forming what we started with plus an infinite tail of 9's. B. So taking any two adjacent new infinite series formed as demonstrated, then their numerical difference resulting from multiplication will always be 8.1 times 10 to the minus power n, where n is the distance of the 0 of the larger of the two series from the decimal point, i.e. 9 times 10 to the minus n minus 9 times 10 to the minus n plus 1 is equal to 8.1 times 10 to the minus n, so that 9 times 10 to the minus 6 minus 9 times 10 to the minus 7 is equal to 8.1 times 10 to the minus 6. The numbers confirm and justify the adopted procedure. 6c. In principle, the integer can never ever get bigger than 9, since to do so would require infinitely plus 1 multiplications by 10, an impossibility. D. The equalities confirm that 0.9999 equals can never equal 1. E. Facts A, B and C show conclusively that 1 can never ever be exactly equal to 0.99999 ad infinitum, QED. Summary. In view of all that has been demonstrated, the only outcome I can come to regarding 1 equals 0.999 ad infinitum is that it represents 1. A deception, 2. A deceit, 3. A lie, 4. Dishonest, fake mathematics, 5. An affront to the honesty and truthfulness of mathematics, 6. Shame on those that perpetrate it in defence of a bit of contrived pretense mathematic trivia alias a left zero and their ill-founded concept of infinitesimals. As a footnote, there is no other way to describe the number equal to the square root of 2 other than by expressing it as root 2, because it cannot be written as a fraction, and any attempt to write it as a decimal could only ever be an approximation, e.g. 1.414213562373 ad infinitum. Fermat's last theorem by Simon Singh. Fortunately for us, the integers are smarter than the math magicians and their meaningless abstractions pretending to be maths. So that's all, folks. Hope you enjoyed the maths, and thank you for watching.